Hello everyone. I am going to speak on the concept of formal charge. The formal charge is nothing but a simple charge only. The formal charge is assigned to atom in a molecule by assuming that electrons in all chemical bonds are shared equally between the atoms. Let's understand this concept by using HCl molecule. In regular HCl bond, the electron is shared unequally. The both electrons are attracted towards chlorine because chlorine is most electronegative atom. So chlorine acquires a negative charge and the hydrogen acquires a positive charge. But in a formal charge, electrons are equally shared, means both the atoms, hydrogen and chlorine gets one electron each. So it forms radical of hydrogen and radical of chlorine. Then the formal charge helps to track of electron in molecules. Means it gives number of electron present in molecule. So majorly it is mostly important to find out number of electron. The formula for calculation of formal charge is number of electron in valence shell minus number of electron used in bonding, non-bonding that is lone pair minus number of electron in bonding divided by 2. It also be find out the formal charge can be also be find out that electron number of electron present in the atom should have and minus number of electron actually having in atom. So then the each lone pair gives two electron because lone pair consists of two electron and the bond pair gives a two electron because bond is formed by the two electron. The formal charge of 0 is most stable because if any charge present on a molecule, then molecule do some reaction to nullify the charge, so it is unstable, highly reactive. But when formal charge is 0, then molecule need not to do any reaction, so it is less reactive and unstable. So for achieving the stability, every molecule tend to acquire the formal charge 0. For the formal charge, two conditions are as follows. The sum of the formal charge of the each atom must be equal to the overall molecule. And the second is negative formal charge. It should on the most electronegative atom, and a positive charge should come on less electronegative atom, or means that is electropositive atom. The reason is that if the positive charge comes on an electronegative atom, then electronegative atom is not accept, capable of accept acquiring the positive charge. It becomes highly unstable. So so the molecules become reactive and its stability decreases. So to avoid that, minimum negative charge should on electronegative atom. It also be called as there should be less charge on an electronegative atom. The formal charge tells whether the atom has more number of electron or the proton associated with it. Initially, the number of proton and number of electron are equal, which is given by the atomic number, which is also called as atomic number. But when during the reaction the atoms donate the electron, then atom or molecule acquires a positive charge because number of electron decreases, so and the number of proton remains as it is, so that the molecules acquires a positive charge. And when during the reaction one atom is gaining the electron, then there is an increase in negative charge, that is increase in electron, so it acquires a positive negative charge. So we took the example of formal charge. We took an example of ammonia. which is formula is NH3. In neutral molecule of ammonia, the nitrogen have a 5 valence electron, one lone pair, and a 3 bond pair. So it forms 6 bond pair, 6 electron. So the formal charge will be 5 minus 2 minus 6 divided by 2. So the answer is 0, which is equal to overall charges, that is 0, which is ultimately stable compound. So on the basis of formal charge, we can conclude that the ammonia is stable compound. Next is ammonium ion. The formula is NH4 plus. Here the nitrogen having the 5 valence electron, no lone pair of electron, and there are 4 bond pair, that is 8 electron. So the formal charge will be 5 minus 0 minus 8 divided by 2, then answer is plus 1. This is also equal to the net charge. So on the basis of formal charge, we also conclude that the ammonium ion having plus 2 plus 1 charge. Then we took example of phosphonium ion pH 4. The formal charge can be calculated by using the Lewis structure. The Lewis structure gives idea about the number of lone pair, and a bond pair, and it also gives the resonance. So we get idea about the more formal charges in deeply. So the formal charge on the phosphorus having the valency 5. Here there is no lone pair and there is 4 bond. Here there is 4 bond. So it create 8 bond pair. So 5 minus 0, 8 divided by 2, so plus 1. And on hydrogen it's having the valency 1 minus 0 as no lone pair and 1 bond pair is there. So 2 divided by 2, answer is 0. Then the nitrous oxide N2O. Here there is a two possibility as resonance is created. Here there is two nitrogen present. So to distinguish this nitrogen, we noted as NC, which is near to the oxygen. It is called as central nitrogen, and which is adjacent to the nitrogen, it is called as terminal nitrogen. So first we took at this nitro N2O. So the formal charge on Nt is that 5 as valency is 5 minus 4 as 2 lone pair is there, that's why 4 minus 4 as this bond pair are there, so 4 divided by 2. So the answer is 5 minus 4 divided by minus 2 gives minus 1. Then the formal charge on Nc, 5 because valency is 5, 0 because there is no lone pair, and 8 because these four are bond pair divided by 2. So the 5 minus 4 gives plus 1. And the formal charge on oxygen, 6 because valency is 6 minus 4 because there is 2 lone pair, and 4 because this is bond pair divided by 2, so the answer is 0. Then we took example of N2O this N2O. Here the formal charge on Nt is 5 because valency is 5 minus 2 as this lone pair, then 6 as 3 bond pair divided by 2, so it gives formal charge 0. Then formal charge on this Nc, 5 because valency, minus 0 because there is no lone pair, and 8 because 3 these 6 and these 2 are bond pair. Divide by 2, so it creates plus 1 charge. Next is Fc on oxygen. 6 because valency is 6, minus 6 because this 6 lone pair divided by 2, this bond pair, so it creates minus 1 charge. So as we see in condition, the formal charge should be 0. So here is on a oxygen, it creates a formal charge 0, which is most electronegative. So for this compound is more stable because most electronegative atoms should have minimum number of charge. Here we took the example of HCN. Here here also there are two resonating structures. So first we calculate for this molecule. Here for sulfur, 6 is valency, minus 2 because this lone pair, plus minus 6, 6 divided by 2 because these 6 are bond pair, divided by 2. So the answer is plus 1. For carbon, the valence is 4, minus 0 because no lone pair is there, minus 8. This 6 and these 2 becomes 8, so answer is 0. Then for nitrogen, 5 is valency, minus 6. This lone pair are there 6, and this bond pair is there. So 5 minus 6 minus 2 is is 2, minus 2. Now we calculating for this. Here the sulfur having 6 valency, minus 4 lone pair, this 4, and there are 2 and there are 4 bond pair. So these are the bond pair. So 6 minus 4 divided by 2. So answer is 0. Carbon. For carbon 4 is valency, minus 0 because no lone pair is there, minus 8, minus 8. These 4 and these 4. So becomes 8 divided by 2. So the formal charge is 0. For nitrogen, valency is 5, minus 4. These lone pair are 4 and minus 4. Bond pair, this one divided by 2. So the answer is minus 1. So the comparison between these, which is more stable. So here this compound is more stable because the most electronegative atom in this is nitrogen, and for the nitrogen there is two possibilities are there, one having the minus 2 charge and one having the minus 1 charge. So minus 1 charge is more stable one. So this structure is referred is accepted. Next is H2SO4. In H2SO4 there is two kind of oxygen. A type, A here we label as A and B. So we took a formal charge of oxygen E, OE. 6 as a valence is 6, minus 4 because this and this is the lone pair, minus 4. This and this is bond pair, divided by 2. sorry, divide by 2. So answer is 0. So the formal charge on oxygen B. Here there is a 6 minus 6 because this 6 lone pair is there, minus 2, this is bond pair. So 6 minus 2 divided by 2. So the answer is minus 1. So the formal charge on sulfur. The sulfur having the valency 6 minus 0 because it does not have any lone pair, and 8. This 2, 4, 6 and 8. 8 electron a bond pair is there, divided by 2. So the answer is plus 2. Then formal charge on a hydrogen 1 because valency is 1, minus 0 because there is no lone pair, minus 2 because 2 this bond pair, divided by 2. So the answer is 0. As in this, the oxygen having the 0 charge, 2 oxygen having the 0 charge, 2 oxygen having the minus 1 charge, and center sulfur having the plus 2 charge. So let's we balance it, minus 1, minus 1, minus 2. So the answer becomes 0. Therefore, though it having the charges, but at final the H2SO4 is 0, unstable, is having the no charges because minus minus 1 balances the my plus 2 charge. So this uh, this makes the H2SO4 stable. Next example is SO4 2 minus. Here the formal, here also there are two types of oxygen. This is one type and this is second type. So let's calculate the formal charge for sulfur. Sulfur having the valence electron is 6. Number of lone pair is 0 because there is no lone pair in it. There are 12 electron, means there are 6 bonds. These two 4, 5 and 6. So 6 into 2 12. So 12 divided by 2, it's 6. So 6 minus 6 is equal to 0. So formal charge on sulfur is 0. Then oxygen. Formal charge on oxygen E. This we calculated as A. A. So the valency is 6 minus number of lone pair is 4. This and this. And number of bond pair is 4. This 4. 1, 2, 3, 4. So 6 minus 4 is 2, 2 minus 2 is 0. Then the oxygen B, this one. For this the valency is 6 minus number of lone pair is 6. This and this one, divided by minus 1 bond pair. So 2 divided by 2. So 6 minus 6 0. 0 minus 1 is minus 1. Here also minus 2 oxygen balances the overall charge as minus 1 is equal to minus 2. So which is equal to the net charge. So from this example we conclude we fulfill the condition that the net sum of the formal charges of each component should be equal to the overall charges. Next example is Al2Cl6, which is dimer of aluminium. Here, here also there are two types of chlorine atom. Here A and B. So the formal charge on a chlorine atom for A, here 7 is a valency, minus 6, which is this lone pair, minus 2 is bond pair, this bond pair, divide by 2. So 7 minus 6 is 1, 1 divided by 1 is 0. So the formal charge on chlorine is 0. The next formal charge on chlorine B, the valency is 7 minus 4 because of this lone pair, minus 4 because this bond pair, to bond pair, divide by 2. So the answer is plus 1. And then the formal charge on aluminum is 3 because it lies in a boron family. So the valency of boron family is plus 3, minus 0 because there is no lone pair of electron. Then there is 8 bond because these two, these two and these two. So total 8 electron divided by 2. So the overall minus 1 charge for aluminium. So in this equation, in this also minus 1 and plus 1 is equal to 0. So it forms 0 formal charge which is stable in nature, Then we compare the formal charge with oxidation state. Here the definition is the formal charge is a charge on an atom in a molecule that we calculate by assuming that electron is chemically equally shared and in oxidation state. And the number of electron we calculate which are lose or gain or share of electron. It means here all the possibilities are accepted. Then the theory, it for a formal charge, it determined the number of electron that occurs around atoms, which means is it gives idea about the whole number of electron. And where in oxidation state, it determine number of electron exchange, means it gives idea but about only exchange occurs during the reaction, whereas in formal charge it gives total number of electrons. Example, the formal charge on a nitrogen atom in ammonia is 0 as we seen earlier, and for an oxidation state of a nitrogen, the ammonia has valence is plus because there is nitrogen is valence is plus. So there is end of topic. Thank you.